Okay, guys, simplifying fractions. Now, look, a lot of what we did with factoring, well, there are a number of things that number of reasons why we factor. One is because sometimes it's easier to solve a quadratic equation that way, okay, by factoring. But another thing another reason why we did it is so that we could simplify fractions. We could make them a little simpler for us to look at. So, for instance, let's take, I don't know, let's just take 24 over 32. Okay, now this is a fraction that we're used to looking at. We could easily reduce this. We could either do repeated division, or we could see that 8 is the greatest common factor. Okay, but I want us to think about this for a second. Let's actually factor 24. 24 is 2 times 12, which is 2 times 6, which is 2 times 3. Am I right about that? Is it 2 times 2 times 3? Okay, so we factored it now. And then if I look at 32, I know that that's actually 2 to the 5th. 1, 2, 3, 4, 5. Okay, now I've factored both of these numbers. This is what's happening when we are reducing, right? We don't do it because it's just faster for us to find the greatest common factor and cancel that thing out. Okay? But this is what's happening. So we cancel out the common factors, and we're left with 3 over 4. Everybody happy with that? A goes into 24 3 times. A goes into 32 4 times. Okay. Now, when we take that same idea and we apply it to fractions or rational expressions with variables in them, what we want to do is we want to factor the numerator, factor the denominator, and then cancel out anything that we have in common. Okay? So, Gordy, I'm going to write this a little larger, and then I'm going to want your help. It says 3a plus 6 over 3a plus 3b. Okay? Now, let's factor the numerator for me, Gordy. Do you see anything that goes into both terms? 3. Okay, so it's going to be 3 times what? 3 times a plus 2. So we have factored the top. Can we factor it any more? Because we always want to factor completely if we can. Is there anything else that we can break that down into? No, that's it. Okay. Now, CB, I'm going to let you help me with the bottom. Is there anything that I can pull out from both terms on the bottom?
3.
All right, so I've got 3 times what?
A plus B.
A plus B. Beautiful. Now I've factored the top and I've factored the bottom. Is there anything that shows up on top and bottom that I can cancel, Kern?
Yes. 3 and the 3's.
Okay, I can cancel the 2 3's. Now, can I cancel the A's, Jackson? Why can I not do that? I'm sorry?
It's one term.
It's actually being added. I've got 2 terms here. I'm adding A to 2 and I'm adding it to B. Because they're separated by pluses and minuses, I can't cancel them. I can only cancel out factors that are exactly alike. Now, if this said A plus 2 over A plus 2 instead of A plus B, then I could cancel them because they're exactly the same. But since this number and this number are not the same, I can't cancel them. Okay? So, my final answer is going to be A plus 2 over A plus B. Okay? Now, there's something that we need to talk about too. What do we know that will always send you to math jail, Troy? You cannot have a 0 in the denominator. Sometimes the problems will ask us to give restrictions. And what that means is, tell us what the variables cannot be. Okay? And what they're asking there is, what would make the denominator 0? Because this is a fraction, we have to say that we start with A plus B equals 0, right? We find out what makes it 0. And then I'm going to actually subtract B from both sides, and you'll see that A equals negative B. If A equals negative B, then that thing equals 0. So what we say is A cannot equal negative B. That's the restriction that we give. Because if A equals negative B, then the denominator equals 0, and then we're in math jail. Okay? So sometimes it will say simplify and give restrictions. So we want to say what the variables cannot be so that the denominator is not equal to 0. Okay? Now, all right, I'll see you guys at the next example.